Okay, so precalc apex 3.5. So rational functions. So rational functions are written in the form, the rational function as a numerator, okay? So numerator of x over denominator of x. Okay, so it's written as a division problem. So you have one polynomial over another polynomial, where n of x and d of x are polynomial functions, and d of x cannot equal 0. So the denominator cannot equal 0, because if the denominator equals 0, then that's not possible. We can't ever have a denominator that's equal to 0. So it's assumed that n of x and d of x have no common factors. Okay. So let's take a look at this. So the domain is all x values except where d of x equals 0. So here, in order to find the domain, I would set that denominator equal to 0 and solve, and I would get x equals -1. So x cannot equal -1. And so our domain would be all reals except x does not equal -1. And you could just write x does not equal -1, okay, because that tells us the same thing. So let's actually take a look at this function. So it says find the domain for the function 1 over x, graph x, and determine the behavior of f near any excluded x values. Okay, so 1 over x, this is actually a parent function. It's called the reciprocal parent function. So f of x equals x is a parent function, you guys know, and the reciprocal of that is 1 over x. Okay, so you can still do vertical stretches, shifts, horizontal stretches and shifts and reflections, okay, the same way you would any other function. Okay, but this one is special. So 1 over x. So let's take a look at what this function looks like. So I'm just going to graph some points. So let's say -4, -3, -2, -1, 0, which our denominator cannot equal 0. So that's going to be an error, right? Or cannot do that. And then 1, 2, 3. Okay, so here I'm going to get -1/4, -1/3, -1/2, -1. Okay, so I'm just plugging these x values in. And here I'm going to get 1, 1/2, 1/3, and so on. Okay, so really what this graph is going to look like is there and there. And it's going to look like this. Okay. So it says, determine the behavior of f near any excluded x values. Okay, so at x equals 0, okay, it's getting closer and closer and closer to 0, but it's never actually touching it. Okay, and we could keep going and we would just keep getting the same thing. Okay, so as we got closer and closer and closer to 0. So let's actually graph this and take a look. Okay, so we're going to have 1 divided by x. Okay? So there's my graph. Okay? And you can see that my lines kind of end right there because my calculator, this is a TI-83. It's a little bit older one. Oh, you guys can't see that. Okay, but let's go ahead and let's look at the table. Okay. And I really want to look at x equals 0 for this one. So I'm going to go into my table and I'm going to change this. I'm going to change it from -1, and I want it to go in, I don't know, let's say 0.2 increments. Okay. So 0.2. Okay. And now I'm going to go to my table. So it's going to start at -1 and it's going to go by 0.2. So you see here, my y values, okay, are getting closer and closer and closer here to -infinity. Okay. At 0, I get an error. And then on the other side, they're going the other way. Okay. So this right here is called an asymptote. Okay. An asymptote, okay, so the line x equals 0 in this case, okay, or x equals some number, is a vertical asymptote of the graph of f of x if, as the function approaches infinity, or the function approaches -infinity. So in other words, as we get closer and closer and closer to that asymptote, okay, this y value gets closer and closer to negative infinity or positive infinity from the left or the right. It's also the same for horizontal asymptotes. So here, there's also a horizontal asymptote at y equals 0. So these values, okay, as y gets closer and closer to 0, over here our x approaches positive infinity, and over here our x approaches negative infinity. So the same thing. In other words, they're getting closer and closer and closer, but they're never touching. Okay, that is what an asymptote is. So let's take a look at how we find these. So vertical asymptotes occur at the zeros of the bottom function. In other words, we're going to set the denominator equal to 0, and then we're going to solve. You want to find vertical asymptotes after you found holes. So holes you want to find first. Okay, and we're going to talk about that and remind you how to do that in just a minute. Okay. So then we have our vertical asymptotes. Our horizontal asymptotes occur at different things. If the top degree is less than the bottom degree, in other words, I have like an x here over x squared, that means this is a 1 and this is a 2. So my horizontal asymptote is y equals 0, okay, which is what happened here. So here I have x to the 0 power, and I have x to the first power, which means y equals 0 is my horizontal asymptote. If the 2 degrees are the same, so I have an x squared, I have a 2x squared over a 3x squared, okay, so these exponents are the same, then it's just going to be the leading coefficient over the leading coefficient. So it's going to be this fraction here. Okay, so it's going to be the line y equals 2/3. If the top is heavier than the bottom, in other words, this is an x to the third and this is an x squared, there is no horizontal asymptote. And there's a possibility that there's something called a slant asymptote, which we will get to in just a minute. But there is no horizontal asymptote. All right, so let's take a look at this. So this one says find the domain, vertical asymptotes, and horizontal asymptotes, holes and zeros of this. And we're also going to add in there the y-intercept, because that's important to be able to find. So the very first thing I'm always going to do is look at the numerator and the denominator separately. Okay? And then I'm going to see if there's a greatest common factor. There is none. Okay? X squared plus x minus 2. I can't take anything out of it. So now I'm going to multiply my a times my c. I get negative 2x squared. And there I'm going to get 1 and negative 2 and negative 1 and 2. And the pair is going to be this one. Okay, I can plug it in, do my factor by grouping, and I'm going to wind up with x minus 1 and x plus 2. Okay. Now I need to factor the denominator, so I'm going to do that the same way. And after I've factored it, I'm going to get x minus, let's see, 3 and x plus 2. Okay, now the first thing I'm going to look for is holes. Okay. So my holes in this case are anything that can cancel top and bottom. So remember, when I'm dealing with rational functions, I can only cancel a binomial with a binomial. So those two would cancel. So I'm going to set that equal to 0 and solve, and I get x equals negative 2. So on my graph, whatever my graph looks like, there's going to be just an open space at x equals negative 2. Now I'm going to look for my vertical asymptotes. This is going to help me find my domain. All right, so my vertical asymptotes, I take the denominator and I set it equal to 0. I've already found my hole, so I don't need to do that one. That is part of my domain, but it is not a vertical asymptote. Okay, so now I'm going to get x equals 3. Okay, so my domain is x cannot equal negative 2 or 3. Okay, so my domain includes both holes and vertical asymptotes. Okay, but those are two different things. So when I have this thing, I'm going to have x equals negative 2 here. And wherever this graph is, it's just not going to be, there's not going to be a point at -2. Whereas at 3, there's not going to be anything the entire length of 3. Okay, so that's a vertical asymptote. That's the difference between a hole and a vertical asymptote. Let's go ahead and look at our horizontal asymptotes. I'm going to go back to the original. Okay, so here it's the same. So it's x squared over x squared, which means I take my coefficient, which means I have a horizontal asymptote at y equals 1. So at y equals 1 here, there's a horizontal asymptote. In other words, there's not going to be anything on that line. My graph is not going to touch it. Okay. And the last thing I need to find here, well, I guess there's 2 more things because I want to find my y-intercept. Let's go ahead and find my y-intercept. Okay, my y-intercept is a point 0 something. Okay, so here I'm just going to plug 0 in for my x's. So 0 squared plus 0 minus 2 all over 0 squared minus 0 minus 6. I get -2 over -6, which is going to be 1/3. So at 0, 1/3 is my y-intercept. And then my very last thing are my zeros. Okay, and to find my zeros, I set my numerator equal to 0. I am not going to use this x plus 2 because it's a hole. Okay, so that one does not get set equal. That's why I find my holes and my vertical asymptotes first, because I don't have to use that to find my zeros. Okay, so I'm going to have a y-intercept, I'm sorry, an x-intercept or a 0, a root at x equals 1. In other words, that's where it's going to cross that axis. Okay, so let's go ahead and graph this on our calculator and see what it looks like. So we're going to have x squared plus x minus 2 all divided by x squared minus x minus 6. All right, there you go. So you can see that nothing touches y equals 1. Okay, you can't see the hole here at -2. Okay, but there's a hole at -2. Okay, and then you see there's an asymptote at x equals, x equals 3. Okay, so I'm going to zoom in and just see if we can see that hole. Okay. We may not be able to. Some calculators show it better than others. Nope. So you can't see it on this one. Okay. But if you go into your table and you go to -2, you see there's an error there. Okay. So that shows you that -2 does not work. So let's go ahead and let's take a look at this next one. So it's going to be the same thing. Okay. So the first thing I have to do is factor this. Well, I have 4 terms here, so I'm going to try factor by grouping. That's always what I try first. So I can take an x squared out, and I'm left with x plus 2. And I can take a -1 out, and I'm left with x plus 2. So now that's going to be x squared minus 1 and x plus 2. But I'm not done because this is an a squared minus a b squared. So that's a difference of squares. So that's actually going to equal, let's see, I'm going to write it in a different color down here. So x minus 1 times x plus 1. And then I still have that x plus 2. Okay, now I'm going to look at this one. Okay, first thing I see is that I can take a -2 out. So then I'm left with x to the 3rd minus 8. That's a difference of cubes. So that's going to be x minus 2. And that's going to be x squared plus 2x plus 4. And you have to memorize that formula. And then this I can actually factor again. And that factors to x plus 2 times x plus 2. And this last one I would factor just by doing my a times c. So I would get 4x squared. What numbers multiply to that and add to the middle, and then do my factor by group. Okay, so I'm just going to move those answers over here. So I had a -2. I pulled that out. Now I'm not going to really be able to use that, but I'm going to go on ahead and bring it over here. And then I have an x minus 2. And then I have an x plus 2, and I have an x plus 2. Okay, so I'm going to find my holes. Okay. So my holes are going to be what cancels. So this x plus 2 and this one can cancel. Okay, so that's going to be x equals -2. Set x plus 2 equal to 0 and solve. Okay, vertical asymptotes. Now I'm going to look at my other stuff here. So I'm going to set -2 equal to 0. I'm going to set x minus 2 equal to 0. And I'm going to set x plus 2 equal to 0. Okay. So here I get x cannot equal, right? So I have vertical asymptotes. I guess I'll go ahead and just leave it as x equals, because we're not on our domain yet. So x equals 2 and -2. So at this point, it looks like -2 is going to be either a hole or a vertical asymptote. Okay, I'm leaning towards a vertical asymptote just because there is another x plus 2 here, but we're just going to leave it in both for right now. And then my domain, we know that x cannot equal -2 or +2. Doesn't matter if it's vertical asymptote or a hole, it can't equal it. Horizontal asymptotes. For that one, I'm going to go back to my original, okay, and they're both to the third. So I have x to the third over -2x to the third, which means I'm going to use the fraction, which is 1 over -2. So there I'm going to get y equals -1/2. Okay, so that's my horizontal asymptote. My y-intercept, I'm going to set x equal to 0 and solve. So on the top, I have 0 plus 0 minus 0 minus 2 over 0 plus 16, which gives me -1/8. So my y-intercept then is going to be 0, -1/8. And that's why I tell you guys, get in the habit of writing that as a coordinate, because then you can go, oh, well, that means my x is 0. So I just plug 0 in for x. And then my last thing is I'm going to find my x-intercepts or my zeros. Okay, my roots, whatever you want to call them. That means the same thing. So I'm going to set anything in the numerator that I haven't canceled out equal to 0 and solve. So that's what x minus 1 equals 0 and x plus 1 equals 0. So here I'm going to get x equals 1 and -1. So now I could graph this if I wanted to, or I can go back and I can double check it. Okay, so I'm going to go to my y equals. I'm going to clear it out. Put a parenthesis, see x to the third power plus 2x squared minus x minus 2, all divided by, make sure you put those parentheses, otherwise it might take the wrong thing, -2x to the third plus 16. All right, let's graph this and let's see what it looks like. I'm going to have to zoom out in just a second. Okay, so I'm just going to go to Zoom Standard because it usually encompasses it pretty well. Okay, so you can see here that at x equals -2, okay, it did not approach negative infinity or infinity from either way. So it's just a hole. Okay, that means it is not a vertical asymptote at that point. It's just a hole. Okay, but at x equals +2, it is starting to approach negative infinity and positive infinity. Okay, so there's an asymptote. And on these older calculators, these TI-83s and older ones, it actually draws the line there. If you have a TI-84, you're probably not seeing that line. Okay, I'm going to go ahead and zoom in just so you can see it a little bit better. And I'm going to scroll over so I'm closer to the 2. Did you guys know you can do that? You can scroll to where you want to zoom in at. Okay, and you can see, so there's my asymptote there, and that's what my graph looks like. Okay. And you can look at the table too. That, that's another way to tell you. All right, so let's take a look now at slant asymptotes. Slant asymptotes occur if there is no horizontal asymptote. In other words, the numerator is larger than the denominator by exactly 1. Okay, so if there's no horizontal asymptote, then there's a possibility that you would have a slant asymptote. if it's 1 is the difference between the exponents. A slant asymptote is just what it sounds like. It's just a line, okay? It's going some way other than vertical or horizontal. So it could be going that way, it could be going that way, it could be going that way. Doesn't matter, okay? But we're going to wind up with the equation of a line. So in order to do that, we have to use division. So here, synthetic or regular, okay, we're going to have 1 minus 1. We're dividing by -1. -1 times 1 is -1, -2. Okay. So here, and then we have our constant here, which is 0. So -1 times -2 is +2, and that's where the remainder comes from. Okay, so here we have x minus 2, and then plus our 2 over x plus 1. All we do is take this portion of it, okay, that line, and that is our slant asymptote. So in this case, our slant asymptote starts at -2 and it has a slope of 1 over 1. Okay, so it's this line right here. So we're going to look at using all of this to graph rational functions. So to graph rational functions, we're going to do everything that we just did on those last 2 problems. These 2, nope, these 2 right here, okay, where we have to find all of this stuff. Okay? So we're going to find the y-intercept. So plug 0 in for x and solve. So we're going to find our x-intercepts. So we're going to set the numerator equal to 0 and solve. Very first, remember that you want to factor these, okay, before you do anything else. And then we're going to set the denominator equal to 0 and solve. Okay. Our vertical asymptotes, we want to find our holes also. And then we want to find and sketch any horizontal asymptotes. Okay, and that's by looking at the exponents. And then we want to plot a couple of points, and we want to finish it out by completing the curve. Okay, so let's take a look at this one. So this one right here, I can already tell just by looking at it what it is. Okay, we're going to go on ahead and do it by hand, but I want to show you, remember that this is called your reciprocal function. Your reciprocal parent function looks like this. But looking at this graph, what has happened to it? Okay. This is really the same thing as writing it like 3 times 1 over x minus 2. Well, that's a vertical stretch of 3, and that's a shift right of 2. Okay, so let's go ahead and let's graph this thing by hand and see what it looks like. Okay, so I don't need to factor either of these. So the first thing I'm going to do is I'm going to find my holes. Okay, there are none. Vertical asymptotes, set the denominator equal to 0 and solve. Okay, so x equals 2. That's a vertical asymptote. Okay. The next step is I'm going to find my horizontal asymptotes. So I have an x to the 0. All right, there's no x up here. Over an x to the 1. So my horizontal asymptote is at y equals 0. Okay. And if you look at this, notice we said it moved to the right 2, but it didn't shift up or down any. Okay. And then we're going to find our x-intercepts. Okay, so we're going to plug 0 in for x. So 3 over, our y-intercepts, I'm sorry. So 3 over 0 minus 2 equals -3/2. So 0, -3/2. I have a point. And then my x-intercepts would be set the numerator equal to 0 and solve. There are none. This thing is never going to cross the x-axis. But if you remember, we have a horizontal asymptote at y equals 0. So nothing is ever going to touch that axis. Okay. And our domain, we could look at our domain. Our domain is x does not equal 2. Okay. And now we're going to go on ahead and we're just going to plot this thing. Okay. So if we take some x's and y's and we plug them in, so we could plug in like -6. We already have 0. Okay. Let's do 1. And then a couple on this side. So let's do, I don't know, like 3 and 6. Okay, so we can plug those in. So 3 over -8. So -3/8. So -6, -3/8, which is somewhere here. Here we're going to get 3 over negative, let's see, -1. Okay. So we're going to have 1 -3. Okay, well, this thing looks like that reciprocal function. Okay. It's just shifted over 2. Let's take a look. If we do this, it's going to be 3 over 3 minus 2, which is 3 over 1, which is 3. So my 3 is going to be at 3 here. If I do 6, I'm going to have 3 over 4. So that's somewhere in here. Okay, so my function is going to go something like that. Okay, and I'm done graphing it. I've graphed it by hand. All right, so let's take a look at this next one. This next one's a little bit more difficult, okay, because we are going to have to factor the numerator and the denominator. Okay. So it says graph x squared minus x minus 2 over x minus 1. Well, the first thing I'm going to do is factor, so I'm going to multiply my a times c. Okay, a times c, and I get -2x squared. Okay, I'm going to get -1 and 2, or 1 and -2. Okay, and this is going to be my factors that add to -x. Okay, so now I'm going to do my factor by grouping. And when I do that, I get x plus 1 times x minus 2 all over x minus 1. So now I'm looking for my wholes first. There are none. Okay, there's nothing here that cancels. Okay, remember, this is one whole part. I can't break this x and this 1 apart, okay, because it's a binomial. The only way I could break it apart would be to factor. Okay, in which case I can't factor that. Okay, so now I'm going to look at my vertical asymptotes. So I'm going to set my denominator equal to 0 and solve. And at x equals 1, I have a vertical asymptote. Horizontal asymptotes. So this is an x squared over an x to the first. So that means I have none. But since I have no horizontal asymptotes, that means I need to look for a slant asymptote. So now I need to divide. So 1 minus 2 divided by this denominator, which is x equals 1. So now I'm going to bring this down. I have a 1. 1 times 1 is 1. That's a 0. 1 times 0 is 0, -2. I don't care about the remainder. Okay, but this is going to be x plus 0. So that's y equals x plus 0. Okay, so y equals x. So the line y equals x starts at 0, 0, and it has a slope of 1 over 1. Draw my points in here so my line's not too terribly crooked when I draw it. Really, you don't have to draw it. You can just leave it as, you know, a dotted line if you want. You don't even have to put the dots in there. But it's nice to do it just so you can see where you're going to graph this thing. Let's see our x-intercepts. So we're going to set each of the factors in the numerator equal to 0 and solve. Oh, that's an x minus 2. So I'm going to get x equals -1 and 2. So at -1, I'm going to have 1. And at +2, I'm going to have 1. And let's go ahead and find our y-intercept. Okay, so our y-intercept, we're going to set x equal to 0 and solve. So that's going to be 0 squared minus 0 minus 2 over 0 minus 1. So that's -2 over -1, which is +2. Okay, so that's going to be right there. All right. So looking at this graph, I know there's a point here and a point here. So I know it's probably going to look something like this. Okay. We want to plug in a couple of points and make sure that that's correct. Okay. Sometimes you're going to have stuff that might fall into this area and this area also. So you want to make really sure that you plug in several points. Okay. So I'm going to plug in -6, -4. I already have my 0. So now I'm going to plug in a few over here. So I'm going to plug in 3 and 6, okay, on the positive side. All right, so a couple of things. I really don't want to plug all of those in by hand. Okay, so I'm going to go ahead and I'm going to come in here and I'm going to put this into my calculator. Okay, and I'm going to show you guys how to put this in your calculator. So we're just going to put it in our y1. So we're going to put parentheses, x squared minus x minus 2, okay, divided by parenthesis x minus 1. Okay, so with that, you can cheat, right? And you can see what the graph looks like. Okay, so I'm going to zoom standard. Okay, so we can see what our graph looks like. Okay, you notice you don't see that horizontal asymptote, and really most calculators, you won't even see that vertical one. Okay? But I don't want to cheat and do that. I want to show you guys how you can actually use your function now. This off. So in our y equals, we have the function. Okay, yes, there is a shortcut. I don't ever follow the shortcut. Okay, so on my calculator, I'm going to go to bars, variables. Okay, I'm going to scroll over on the top to y variables. It's a function we're dealing with. Parametric and polar you'll deal with later. I'm going to hit enter. And then my function is entered into the y1 on my y equals screen. So that's the one I'm going to choose. So now it says, hey, a function of, now I'm going to put my x value in. My first x value I chose was -6. Make sure you're using the negative sign and not the minus sign. Okay, so -6. I put it in, close that parenthesis, and it's going to solve it for me. Okay, sometimes it's easier to use this, sometimes it's not. It just kind of depends on the function. Okay, but I just wanted to remind you of that, and I'll make sure that in the Google Classroom there's a handout that can help you guys with algebra or your calculator functions. Okay, so for this I'm going to get about -6. Okay, so -6 would be about -6. So that's going to be somewhere right in here. Okay. So, you know, so I'm on the right track. And if you looked at the graph, you could see that it was the same. So for -4, I would do the same thing. And in parentheses, put -4. Okay. So I just went in and I did the same thing. And I get -3.6. Okay, so -3.6. So -4 is -3.6. Okay. So you can see that my line kind of follows that. Like I said, you really want to check because sometimes you might wind up with some stuff here and here. In this graph, you don't. And you'll see that when you finish graphing it, it actually comes up and just follows those asymptotes. Okay, remember, that's what an asymptote is. Okay, so even a slant asymptote, as you're following the slant asymptote, your y values, your range is going to get closer and closer to positive infinity and negative infinity along that slant asymptote. Okay, because at an asymptote, you're always approaching infinity or negative infinity. Okay, so I would make really, really sure that you guys have how to find all of these things. Okay, on a note card, make sure you memorize them. That is very important. Okay? And you guys have a great day, and I will talk to you next time.